Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to look at the long division algorithm. Now, notice the key word, understanding it. Many of us, when we learn the long division algorithm, learned it as a set of procedures. If we've taught it to children, sometimes we use memory devices to help them remember the steps for the algorithm. But there's more to it than that, and we really want your child to understand what is going on, not just try to recall steps in it. Now, I've put out some manipulatives. You've seen these if you've watched the standard algorithms for addition and subtraction, and those links will be left in the description below. But these base 10 materials help your child understand quantity and place value. Give them a model for that. Now, you notice how I have commercial ones, the 3D ones, and I've got my paper version. These are made out of centimeter grid paper. And one thing I do want to point out, just as an aside, do you notice it doesn't matter if I put them hundreds, tens, and ones to know that this is 236. The model tells me that. I've got 2 hundreds, 3 tens, and 6 ones. I must have 236. Now, again, in the other two discussions, the one for addition and subtraction, I talked about a foundational piece for understanding an algorithm is understanding equivalency. So I'm going to take this away for a second. We'll come back and use some of these pieces. And I want to think about equivalency. Now, essentially, what we need your child to understand is that there are many ways to make a quantity, and I'm going to pick 236, which you've already seen that model for. There are many ways to make that quantity using hundreds, tens, and ones. Many of us see this and immediately think, well, I can make it with 2 hundreds, 3 tens, and 6 ones. And that's true. That's absolutely true. But see, we want them to also understand, well, you could make it with 236 ones. You could make it with 23 tens and 6 ones. You could make it with 100, 13 tens and 6 ones. You get the idea. That equivalency is really important. Now, in the addition subtraction videos, I talked about how important it is to think about also which way of making it uses the fewest number of pieces and which way uses the most pieces. Now, I'm showing you this for whole numbers. We can also do it for decimal numbers. We can use this idea for fractions. It becomes very important when we want to add and subtract mixed numbers, especially subtracting with that regrouping piece. But understanding this and becoming comfortable with this is a key to understanding the different standard algorithms. Now, I'm going to stick with 236, and I'm going to come back to those pieces that I first had out. So I had out 230, and I had 3 tens and 6 ones. So that's thinking about it in that base 10 way of looking at it. Now, let's say that I wanted to separate 236 into 4 equal groups. And I'm just going to fold a sheet of paper into 4 sections to help us with this. But as you're thinking about it, just look at these pieces. As they are, I can't separate 2 100 pieces into 4 equal groups easily, or 3 tens or the 6 ones. See, this is where equivalency comes in. So keep that in mind and listen to this language because you're going to hear it again when we get to the actual algorithm. Okay? So I folded my paper into 2 equal sections, and as we said, I can't just take these 200s as are, or the 200s and the 3 tens as are, see? I can't necessarily take those and separate them to 4 equal groups, but I could replace the 200s with 20 tens. that would give me a total of 23 tens. See, and then think about what I can do. I could put 5 tens there, and your child can just kind of play with it at first, right? They can put an equal number of tens in each group. And I had 20 there. Let's see. 5, 10, 15, 20. And then what happens? I'm left with 3 tens. But I also have the 6 ones. So right now I've got 50 in each group, and I have these 6 ones and 3 tens. But what's an equivalent way to think of 36 with the 6 ones and 3 tens? Well, I've got the equivalent. I could think of it as 30 here, so 36 ones. And I can separate these. Now, I hope you trust I put them into groups of 10, so I'm going to end up putting 9 in each group. But do you see how I'm thinking of equivalent ways to make those quantities using tens and ones? And I'll end up with 59 in each group. Now, let's go to the long division algorithm and listen to my language. And I'm going to talk about it in a way that many of us might have heard it talked about, might have heard the language. I remember learning this and hearing 4 doesn't go into 2. But see, we want your child to understand place value. We aren't separating 2 into 4 equal groups. We're separating 200. So we'd hear 4 doesn't go into 2, 4 doesn't go into 20, or 4 goes into 23. How many times? But see, that's 23 tens. So think about it. I can take the 200. I have 23 tens separated into 4 equal groups. So I can think of it as 2 hundreds, 3 tens, 6 ones, or I could think of it as 23 tens. And if I want to separate 23 tens into each group, how many could I put into each group? Well, I could put 5 tens in each group. And how many tens would I use up? I used up 20 of my tens, as you saw when we were doing this, and that left 3 tens that I had. Now, I couldn't separate the 3 tens into the 4 equal groups. So when we had this was my 4 equal groups. Right now, I've got 5 tens sitting in each of these groups. Right? And I've got 3 tens left over. Well, and I've got these 6 ones. So I can think of this as 3 tens and 6 ones, or I could think of it as 36 ones in equivalent way. Well, if I have 36 ones and I'm going to separate them into the 4 equal groups, right? I'm going to end up getting 9 in each group. So if I put 9 in each group, 9 ones in each group, I will have used up all 36 ones. Okay. So that algorithm is thinking about how do I separate into these groups, but I'm not treating this as a 2 or a 3. I'm thinking, oh, these are hundreds and tens, but I could think of it as the equivalent way. Let's do one more example. Let's do, I won't go much higher, 371. And let's separate this into 5 equal groups, right? So we're going to do 5. Now, again, if I think of this as 300s, I can't use those, but I can think of this as 37 tens. So I'm going to take the 37 tens and separate in each group. I'll be able to put 7 in each group. That'll use up 35 of my tens, leaving me with 2 tens left over. Now, I have this 1, so I can think of this as 2 tens and a 1. Or I can think of this as 21 ones. And if I separate this into 5 equal groups, I'll be able to put 4 in each group. That will use up 20 of them. I'll have 1 left over. Now, I can either write this as a remainder of 1, right? We'll have 1 individual left over. Or I could also think of this as taking that 1 unit, that little piece. See if I have it here handy. I could think of taking this little piece and separating it into 5 equal pieces, which would make each piece worth 1/5. So that's the algorithm. But what we want your child to think about to understand the algorithm is understand that equivalent. It's not that 5 doesn't go into 3, because 5 will go into 300, right? But it's understanding with that algorithm. I can think of it as 307 tens, or I could think of it as 37 tens that I'm separating into the groups. So you may see your child doing things with these pieces early on. And what they're doing, it's not instead of learning the algorithm, it's building the understanding of equivalency. It's actually acting out this algorithm before we get to all the symbols. I hope that's helpful in helping you understand why you may be seeing what you're seeing with long division. See how this idea of equivalency comes into play again when we look at division. If you found this video helpful, please give it a thumbs up. Please share it with others. Consider subscribing to the channel. It's free. It does help the channel if you would do that. Get this out to other folks. And please turn on that notifications bell so you'll know when other videos are coming. Now, I'll be doing videos this month. We'll have 1 more, I think, in June, and then we'll take July off and then come back in August. So again, I hope you found this video helpful. Look in the description below for links to other videos related to the standard algorithms and also some other playlists that you might find helpful. Thanks so much for watching.